Lab 7, Animation. In this lab, we are going to learn how to create animation in Maya. There are several methods, including keyframe, motion path animations, and drive key. At the end of this lab, we are going to try a function called paybus. Let's start. Keyframe is one of the popular methods to set up animations. Keyframe records the state of the object at different times, and then the software will automatically help us to twinning between keyframes. To set up keyframe in Maya, first we have to change to the animation menu, and then under key, we can find the set key command. The shortcut key of this command is S, so we can also press S to set the key. In Maya, please remember, the key is stored in the object. So when you want to set a keyframe, first we need to have an object, select it, and then we can use the command set key or the shortcut key S to set the keyframe inside the object. Okay, let's try it out. First, I create a sphere, and then I select the object. Pressing S, you can see the wet vertical line is created. So this is the keyframe. When I deselect the object, you can see the wet vertical line disappear. So the keyframe is stored in the object. When we select the object back, you can see we can see the vertical line again. All right. So please remember the key is set into the object. So we have to select the object to set the key, and also when we want to see the key again, we have to select the object again. If we only want to move the object, animate it by translation, we only need to set the moving keyframe. If we want to set the moving keyframe, we can use Shift W, which is the shortcut key of setting moving keyframe. For rotations, we use Shift E. For scaling, we use Shift R. W, E, R are the shortcut keys to switch to translation tools, rotation tools, and scaling tools. So adding the Shift key, you are setting the keyframes of those transformations. When we want to remove the keyframe, just need to right click on the red vertical line and then choose delete. Then the keyframe is removed. We can use Graph Editor to help us to fine-tune the animations. Under Windows, Animation Editors, you can find the Graph Editor. This editor is quite similar to those in Adobe Premiere, After Effects, and Animate. So I'm going to skip this because I think you should have some experience in using those editors in the Adobe software. Certainly, you are welcome to contact me if you have any problems when you use the graph editor. Next, let's talk about the motion path animations. When we want to move the object along a path, then we can apply these motion path animations to make the effects. Let's try it out. First, we need an object. So we have a sphere here already. Then we need a path. So I'm going to use the CV curve tools to help me to draw a path. So I switch to top view and then I draw the path out. It can be a open path or a closed path. So I press enter to complete the path and then I go back to modeling menu set Under Curves menu, use the Open Close command to help me to close the curve. Next, we need a locator. We go to Create and then choose Locator. Locator is an object that will not be rendered, so we cannot see the locator in the final outcome. We are using this locator to attach the object to the path and then animate it along the path. So the next step, we select the locator first and then pressing Shift key, click on the path. We choose the locator with the path and then we change the menu set back to animation. Under constraint, we can find the motion paths and then we can choose the attach to motion path. Now, if you play the animations, you can see the locator is moving along the path. Final step, we select the object first and then select the locator. If you find that it's hard to select the locator, you can also use the outliner to help you to select the locator. Open the outliner and then by pressing Ctrl key, click on the locator. So you select the sphere with the locator while selecting the object first and then the locator. Then you can use the command edit parent or the shortcut key P to create a parent-child relationship between the object and the locator. So you can try to play the animation now. So you can see the ball is moving around the paths. Drive keys. Drive keys is similar to normal keyframes, but the difference is normal keyframes change the value along time, while drive key changes the value along another value. That means one value affects the other. Drive keys are mostly used in racking. It can connect two values together. That means one value be the driver. It affects another value. The values affected by the driver, it is called driven. So let's try drive key in Maya. First, we need two objects. Let's create two cubes side by side. Okay, create the first one and then duplicate it. Move it a bit. So we have two cubes now. Go to animation menu set. Under key, we can find the set driven key. Click at the option box of the set command to open the set driven key panel. We select the cube on the right and then set it as driver. So in the set driven key panel, when we select the cube on the right, we click the button load driver to make it as a driver. So you can see pcube2 is now a driver. And then we select the left cube, back to the set driven key panel, click the load driven button. So you can see pcube1 is now the driven object. You can see the keyable attributes on the right hand side, and this time we are going to set the relationship between translate Y and the rotate X. That means when the driver moving up and down, the driven will rotate. First, we go to driver, click on translate Y to select it, and then we go to driven, click on rotate X to select it. Indeed, we can select more than one attribute in the driven to make it related to translate y. That means once the object moving up and down, it can affect more than one values in the driven. But this time we stick with one values first. After selecting the translate y in driver and rotate x in driven, then you can see the key button is available to click on it. So the next step, we click the key button. So it set up the relationship between translate y in the driver and the rotate x in the driven. Next step, we need to move the driver a little bit upward. So we go to channel box, change the translate y value to 2. Okay. And then we select the driven. That means the curve on the left hand side. You can see the rotate x has a blue tag here. So we key in 45 to make it rotate 45 degrees. After changing the values, we click the key button again. So it set up a new relationship between these two attributes. Now the translate y is 2 and the rotate x is 45. So after these two actions, the relationship between translate y and rotate x is set up. When translate y is 0, rotate x is also 0. But when translate y change to 2, rotate x will change to 45. So we can try to move the cube on the right up and down and see the result. So moving down, moving up, you can see the cube on the left. That means the driven is rotating. We can check out the relationship between in the driver and the driven. We go to Windows, General Editors, and then Hypergraph Connections. In this panel, you can see here pcube1 underline rotate x. We can select it, and then in the attribute editors, here we can see the relationship between the driver and the driven. When the driver translate y is 0, the driven rotate x is 0, 2. When the translate y change to 2, the rotate x change to 45. Okay, here we have two settings we can adjust. One is called pre-infinity and other is called post-infinity. You can see the value now is constant. That means when translate y is less than 0, the rotate x is kept as 0. When we move the cube on the right up and the translate y is larger than 2 now, you can see the rotate x is kept at 45 degrees. That means it keeps the values as constant. So let's try out another settings. For example, we can try cycle. Okay, we set both of the values to cycle and then move the cube up and down. You can see the cube on the left hand side rotate repeatedly, but it is not the result we want because it keeps rotating between 0 to 45 degrees. So let's try out the cycle with offset. Okay, and then here you can see this is the result we want. The cube on the left rotate continuously. The cycle with offset settings means the cube on the left will rotate by accumulating the values. That means when the translate y larger than 2, it add the rotation angles to 45 and keep rotating it to more than 45 degrees. So when we move the cube ups and downs, it keep rotating. From this example, you can imagine you can create a car with the wheels, and then when you move the car, the wheels can rotate when the car moves. So you don't need to set keyframes separately on the wheels and the car. You just need to set the driven key between the wheels and the car, and when you move the car, the wheels rotate with the car moving. In the last session of this lab, I would like to introduce paybars to you. Before I talk about paybars, okay, beware of this. After you set up the driven key, okay, if you click the pay button, you cannot see the cubes are moving because we didn't set keyframes to move the cube. So here, let's set up some keyframe to move the cube on the right up and down. Okay, I select the cube on the right, and then the time slider is now at frame 1. I press S to set up the first keyframe, and then I move the time slider to the last frame, that is the 120. I move the cube up maybe until 8. Okay. And then I press S again to set up the second keyframe. So you can see now the cube is moving up and the cube on the left is rotating. You can see the speed. It is quite fast. Indeed, it is not 24 frames per second. In Maya, when you use the preview, the speed depends on the performance of your computer. If there is not much objects in the scenes, you can see the animation can play in a very fast speed. But if there are a lot of objects in the scenes and it consumes a lot of the resources in your computer, the payback speed might not be able to fast as 24 frames per second. So we need some things to help us to play the animation in true 24 frames per second. So here we have the paybars functions. Paybars is a function that helps us to render the viewports in true 24 frames per second. Because it only renders the viewports, that means it will not calculate the effects of lighting, texture, etc. So it can render the animations out in a very fast speed. So we always use paybars to help us to determine the view speed of the animations. Once we set up the keyframes or the animations, then we can use the paybars functions to help us to see the view speed of the motions. So let's click on the option box of the paybars command to see the settings. First, we can set the time range to be rendered. If we choose time slider, the animation will play from as many frames that are in the time slider. In this case, from frame 1 to frame 120. Also, we can choose start and end, and then define the start and end frames in here. Next, it is the view attributes. If we unclick it, then the animation will be saved as a file. If we click it, when the animation is rendered, it will open the video files by your default player to let you watch the animations. When the show elements is unchecked, the stuff on the interface will be hidden. By default, the video will have the resolution is equal to half of the viewport size. We can change the setting to follow the render settings or define the resolution by choosing custom and then set the numbers here. The remove temporary files is always checked because we don't want to keep the temporary files to save the hard drive space. If we want to keep the paybars file for reference later, we can save the rendering to a file, and the paybars video will be saved under the movie files in the project folder. So let's try the paybars now. Click the paybars button, and then you can see it's rendered. And then once it's finished, it used the default video player to show the videos to you. So when the speed is 24 frames per second, you can see this is the real speed of the motions. That's the end of Lab 7.